What's up, guys? Going to talk about your learning target for this week now. A little bit of a different week because we are going to give you all the material up front, so it's kind of on your own. There's 3 or 4 steps that should take about a day each, maybe less. So we're going to talk about periodic trends. We've been talking about trends a lot, or we've done talking about the periodic table a lot, and we're just going to talk about 2 different trends that exist on the periodic table. The first one's called atomic radius, and it's exactly kind of how it sounds, but the definition is the distance from the center of an atom to its outer edge. So basically what you're talking about is you're talking about from the center here, let's get red, to the outer electrons, which we call valence. So that's the radius, all right? And there's a general trend you can see here that the biggest atoms are down in the lower left-hand corner. Francium doesn't really exist, but it theoretically would be the biggest atom on the table. That's the largest. And then the smallest atom on the periodic table is helium. So what you can see is that it gets bigger as it goes down a group, and it gets smaller as it goes across a row. Okay, so that's the general trend, and you can see it here, and you're going to graph it as you tomorrow, but that's the general trend for radius. Why does it? Here's just the explanation of why. So as you go across a period, the radius gets smaller. Okay, so what we say is there's this thing called nuclear charge. All right, and the best, simplest way to describe it is as you go across a row, you add more protons. So the stronger it is, it's going to pull in it tighter. Okay, so in this instance, you can see so these are all in the same row. Add a proton, gets smaller. Add a proton, it gets smaller, and pulls and pulls and pulls and pulls and pulls and pulls. So you get to the noble gas, which makes it really small. If we were to look at a periodic table, what you could see, okay, on this is that as we go across a period, big, smaller, we're adding protons, 13, 14, 15, 16, 17, 18, it gets smaller, okay? But that's the general trend as we go across. It's called it's called effective nuclear charge. It's all in the same row, and we're adding more protons that pull it in tighter. Okay, so that's the idea of the why. All right. As you go down a group, they get bigger. Okay, so what happens is we go down a group, they get bigger, and the reason why is because we're adding layers, and the nucleus can't pull the electrons in tighter. Okay, so as we add layers to it, it gets farther out, so they can't pull the nucleus positive can't pull these negative electrons in. Alrighty, that's just the why we makes it hard for the nucleus to pull in the electrons. So back to our graph, as we go down a group, you can pick any group, it gets bigger. We're adding layers. They get bigger. The electrons get farther out there, and the nucleus can't pull on those electrons. So that's the why for atomic radius. In summary, smallest atoms, biggest atoms. Okay, that's what you need to know about a radius. From that, you can figure out anything really. Okay, the next trend is called electronegativity. All right, we talked about this idea that every electron wants 8. All right, the ability of an atom to attract atoms' electrons when bonded to another atom. So basically what that summary is this: how bad does it want electrons? Okay, now if you remember, valence electrons 1, 2, 3, 4. Oh, 4 is hard on this. 5, 6, 7, 8. Okay, everything wants 8. And the ones that have the highest desire for electrons are the ones that are in 7. Okay, have 7. They have a high desire for electrons. They really want to get an electron really bad to get to 8. Now these ones over here, the metals, don't have a strong desire for electrons because they want to lose 1 to get to 8. Okay, so how bad do I want to get to 8? Now here's a chart. Okay, basically this chart is saying this. It's an arbitrary value. 4.0 is the highest value for desire of electrons, all right? And that's fluorine. So fluorine is what I call the sexiest atom on the periodic table because it really wants to get to 8. The least electronegative atoms would be francium, okay? So the biggest atoms are the least sexy atoms, or the ones that want the atoms the least. The smallest atoms are the sexiest atoms because they really want electrons, all right? So if you look at this chart here, it shows you here that electronegativity increases going this way. It's opposite of atomic radius, all righty? So in summary, smallest atoms are up here, biggest atoms are down here. The ones that really want electrons to get to 8 are up here. The ones that don't want electrons are down here. Okay, they're opposite of each other. So now what you're going to do is you're going to fill out this Google form. Okay, just to help you summarize this lecture. Okay, just about 10 questions, just basically all that I talked about. All right, it's not worth anything, just to help for us to see that you know what you're talking about. Okay, and it should be there's 2 sections: atomic radius, and then there's electronegativity. Okay, so turn that in and you're done for the day. Okay, guys, awesome. Let us know if you got any questions.